So in this video, we're going to see an operating system 2 marks question from the year GATE 2015. It's based on the topic of CPU scheduling. So the question reads, for the processes listed in the following table, which of the following scheduling schemes will give the lowest average turnaround time? So we have 4 processes, there are 4 arrival times and there are 4 processing times, and we have 4 possible scheduling algorithms. Now for each of these scheduling algorithms, we have to find the average turnaround time, and once we find the average turnaround time, we have to pick the lowest one. Now before we start with the solving the question, let's see quickly the definition of turnaround time. So turnaround time is nothing but it is the difference between arrival of the process. So this is the arrival of the process. A process arrives at this time, and at this time the process gets completed. So the time spent between the arrival of the process and the completion of the process is called as the turnaround time of that process. So we have arrival of the process for all these 4 processes. What we need to find is this, the completion time of the process. Once we find completion time of every process, turnaround time can be just found out by their subtraction. So let's start. We'll start with the first algorithm, which is FCFS. Let me zoom in here. Okay. Yes. So we have something called as ready queue. So let me write here down, ready queue. Okay. So at arrival time 0, process A arrives. So it goes into the ready queue. Now A doesn't have any competition, so A immediately gets picked up for our CPU running. It goes into the running state from the ready state. So this is my time 0 and A gets picked up. So A gets picked up here. Now since we are following first come first serve, A is out of the ready queue. A will keep on running till it completes its processing time, which is 3 seconds. So from 0 to 3, A will keep on running and then A will go out of the system. Now by the time A was running from 0 to 3, at 1, B had arrived. So B had already arrived into the ready queue. Now at the 3rd second, B will be picked up from the ready queue and it will go with the CPU. Now again, B will keep on running because we are following first come first serve. B will keep on running till its entire processing time, which is 6 seconds. So from 3 plus 6, 9, till 9, B will keep on running and then B will go out of the system. Now when we reach this 9th second, another 2 processes, C and D, had already arrived into the ready queue. So let's note them down, C and D. Now again, we are following first come first serve. So the next process after the 9th second, C will be picked up. So C comes here. Now what is the processing time of C? Processing time of C is 4 seconds. So from 9 to 4, which is till 13, C will keep on running and then C goes out of the system. And finally, if you look at the ready queue, we have D. So D gets picked up, it has no competition, and D will run. What is the processing time of D? It's 2 seconds. So D will run for next 2 seconds from 13 till 5, and then D will go out of the system. So thus we have implemented first come first serve for all these 4 processes A, B, C, D. Now let's first clean up this mess. Now let's note down the completion time of every process. Okay, so the completion time of process A is 3. So let me note it down here, 3. For B it's 9, so this becomes 9. For C it's 13, so this is 13, and for D it's 15, so this is 15. So thus we have both the arrival time and the completion time of every process for first come first serve algorithm. So now we can find the turnaround time. Turnaround time is the difference between the arrival time and the completion time. So 0 minus 3, 3, 9 and minus 1 is 8, and 13 minus 4 is 11, and 15 minus 6 is 9. So if you do the summation of this, it will be 11 and 9, 20, 28, 28 and 3 will be 31. So 31 divided by 4, that is equal to 7.75. 4 is 32, yes. So 7.75 becomes the average turnaround time for option A, first come first serve. Now next we will go with the option B, which is non-preemptive shortage of first. So again, let's clean this up because we will need this for next algorithm. So ready queue is gone and our CPU running is also clear. Okay. So now we are going to implement non-preemptive shortest job first. So again at time 0, A is already into the ready queue, so A gets picked up without any competition into our CPU. So A is here. Now in the first second we have B arriving, so B comes into the ready queue. Now we have to implement shortest job first. However, it's non-preemptive. Non-preemptive as in once A gets selected with the CPU, you cannot preempt it. So A will continue to run till it completes its entire process. Okay. So A will continue. The processing time of A is 3. So A will continue till it completes its processing, and then A goes out of the system. Now when we have reached third second, again we have B in the ready queue. B has no competition, so B gets picked up. Now B will also, it's a non-preemptive algorithm. So B will also keep on running till it completes all its processing time. So from 3 to 9, B also carries on. Now as before, at the 9th second we have C. By the time we reach 9th second, we have C and D arrived into the system. So C and D has already arrived into the ready queue. Now after 9th second, when we have to pick up, we have two options, C and D. So we will use shortest job first algorithm. So which one is the shortest among 4 and 2? 2 is the shortest. So D gets picked up here from the ready queue, and D runs for its entire batch of 2 seconds. So from 9 to 11 D runs, and then we have only one process remaining into the ready queue, which is C. So C gets picked up, and C's time is 4 seconds. So from 11 to it will go till 15. Okay, and then C will also go out of the system. So thus for the algorithm number B, non-preemptive shortest job first, we have the completion times. For A it is again 3, so I'll note it down here 3. For B it is 9, so I'll note it down here 9. For C it is 15, so I will note down here 15, and for D it's 11, so I'll note down here 11. Now let's calculate the turnaround times. The turnaround time is the difference, 3, 9 minus 1 is 8, 15 minus 4 is 11, and 11 minus 6 is again 5. So the total is 11 and 5, 16, 16 and 8 is 24, 24 and 3 is 27. Yes, 27 divided by 4 is 6.75. So 6.75 becomes the average turnaround time for option B. Now once again let's clean this up because we need it later on for next algorithm. Yes, let's clean the ready queue, and let's also clean this CPU running. Okay, so we have two candidates, 7.75, 6.75. Now let's see what happens with C, shortest remaining time first. Now again at 0 we have process A coming into the ready queue, so I'll note down A. A has no competition, so it directly comes and starts running with the CPU. Here comes A. Now at 1 B comes into the system, so B comes into the system. Now we have to follow shortest remaining time. So remaining time of A is 2 because it has completed 1 second with the CPU. So 2 is remaining, and we have B into the ready queue, and B's remaining time is 4. So we have to pick the shortest remaining time. So A continues. So A will again continue till 3. Okay, so A will continue till 3, and then A will go out of the system. So A finally goes out of the system. Now at the third second, if you look at the ready queue, we have only B. So B gets picked up. So I'll write here B, and B starts running until 4. Now at 4th second, yes, at the 4th second, we have C entered into the system. Now B has spent 1 second in the CPU, so B's remaining time is 5, and C has come into the system. C's time is 4. So we have to follow shortest remaining time first. So as per this algorithm, C gets picked up. So B is preempted. B goes back into the queue, and C gets picked up. So C gets picked up here, and now C will keep on running till the next process comes, which is at 6 seconds. So till 6 C keeps on running, and by the time it reaches 6 seconds, C will have 2 seconds of its time remaining. Now at the 6th second in the ready queue, we have D enter into the system. So I'll note it down here D, So now we have B in the system, D in the system, and C also, and C has 2 seconds remaining, and D also has 2 seconds remaining, and B has 5 seconds remaining. So C will continue because it's 2 seconds only remaining. So C continues till 8, and at the 8th second C goes out of the system. So C is gone. Now we have only two. Do I have space here? Yes. Now we have only two processes remaining, B and D, and clearly D has shortest remaining time. So D gets picked up here. It runs for 2 seconds. So till 10 it will run, and then D goes out of the system. And now finally what is remaining is B. So 5 seconds of B are remaining. It will run for the entire 5 seconds from 10 to 15, and this is where the B will terminate. So now once again let's find out, let's note down the completion times of every process. So the completion time of A is here 3 seconds, so I'll note down here 3. The completion time of B is here 15 seconds, so B got completed at 15 seconds. The completion time of C is here 8, so C got completed at 8, and the completion of D is 10, so D got completed at 10. Now let's calculate the turnaround time. The turnaround time is for A is 3, for B is 14, for C is 4, and for D is also 4. Now if we do the summation, it's 4 and 4 8, 8 and 14 is 22, 22 and 3 is 25. So 25 divided by 4, that is 24, 6.25. Oh, we have got a shorter time, 6.25. So these two have actually gone out of the competition now. A and B cannot be the option. It's between C and D, because we have to find the lowest average turnaround time. So now we have last algorithm remaining. Let's clean this. Okay, let's clean this ready queue and this all CPU running. Okay, so now we have the final algorithm, which is the round robin with the time quantum of 2 seconds. So again let me just zoom in a bit. Again at the 0th second we have A coming into our ready queue. A has no competition, it gets picked up by the CPU at the 0th second. Now A will run for 2 seconds because we are doing round robin with the quantum of 2. So A will continuously run for 2 seconds. So its processing time will become 1, it will reduce by 2, and then by the time it reaches 2 seconds, B has already arrived into the system. So B comes here, and then at this point A goes back into the ready queue, and B gets the CPU. Now B runs till 4, and at the 4th second B also will be moved out of the system, and C has also entered the system at the 4th second. So B goes out because of the time quantum, and C enters at the ready queue. Now here is our A. A will come again with the system, and it will now, if you look at this, A has only 1 second remaining, so A will terminate at 5. This is where A terminates. B has ran for 2 seconds, so its processing time will now be 4. 2 seconds are gone. Okay, now at the 5th second we have two processes in the ready queue, B and C. So B gets picked up because it has 4 seconds, it's in the ready queue. So B comes here, it will again run for 2, so it will run till 7. Now while B was running here, at the 6th second D had entered the system. So let me note down here, D came into the ready queue. So at the end of the 7th second B gone, so I will reduce this by 2, and B again goes back and sits into our ready queue. So let me just note it down here. B goes back into the ready queue. Now next is C. C is picked up from the ready queue, and C comes here, and C has 4 seconds remaining, but it will get only a time quantum of 2. So this becomes 2 now. Then C is brought back into the ready queue because we are doing round robin with a quantum of 2 seconds. And who is next? Next is D now. So D gets the CPU. D has only 2 seconds, so D is over. D gets finished by 11 seconds, so D goes out of the system. Now we have only two systems remaining, two processes remaining, B and C. So B, once again, if you know, B has 2 seconds remaining, so it will run with the CPU for 2 seconds till 13. Okay, and then B will also terminate, and then finally, yes, and then finally we have only C remaining. C has also only 2 seconds remaining, so it will get the 2 seconds time quantum, and C will also terminate. Yes, this is how round robin will happen with the time quantum of 2 seconds. Now let's quickly note down the completion time of every process. It looks a bit messy, but let's try. So A is here 5 seconds, so A got completed at 5. Then B got completed as 13, so B got completed at 13. Then C got completed at 15, so C got completed at 15. And D is here, D got completed at 11, so D got completed at 11. So once again, if we find the turnaround time, it's 5 for A, for B it's 12, for C it's 11, and for D it's 5. So if you do the summation, this is 5 and 5, 10, 20, 30, 33, and 33 divided by 4 is 8.25, which is this 8.25, which is also out of competition. So the shortest, the lowest average turnaround time is 6.25, which is our option C. So option C is the right answer.